I'm going to talk about this perfect squares. Okay, let's just jump into the examples. I hope you have already read the descriptions. For example, here we have number 12. Then we choose from the square numbers. For example, I choose 1, then the rest is 11, then I choose 1, the left is 10, then finally I choose 11, then the rest is 0. So I break down the big problem into the subproblems. The original problem is to get combinations of 12, and the subproblems I break down is get the combinations of 11, get the combinations of 10. So the structure like this is I break down the big problems into the subproblems, and once I solve the subproblems individually, then the big problems is also solved. The structure like this it's very it's very natural to use dynamic programming. Think of what is dynamic programming. It builds from bottom up. You solve smaller problems. For example, here, let's say how to build the summation of 4. Okay, I can only choose 4. Then I have one choice. Then how do I build square 8 in this example? Then I will choose, okay, I will build 2 4s. Then the summation is 8. So the problem like this reminds me of a cutting road problem. So what is the cutting road problem? It is a textbook question from Introduction to Algorithm. It's a classic algorithm book. In this, so for the cutting road problem, it says I have a rope at length n, and each length has, I can either cut it or not cut it. I can only cut into 1, 2, 3, to n pieces. And the problem is to say each length has a price. Then I want to know how to cut the rope such that the revenue is maximized. So in that problem, let's say at a random length j, we can cut it into length I plus length j minus I. Here the length I can be 0, so this actually includes all the cases. So my revenue at length I is the maximum revenue of all this. For example, here if I don't cut the rope, then my revenue would be just simply 0 plus the revenue. Or if I cut this rope into length I and length I minus 1, then the price would be price 1 plus here the revenue of my previous revenues. Or another example, if I cut this length j into length 2 plus cut into length 2 and length j minus 2, then this is my revenue. So then I will iterate, I will loop through all the possible i's. In this example, I is smaller than j, then the revenue, our final revenue is the maximum of all the ways I can cut. Okay, let's go to the textbook. This is the code of my explanation on the right. Oops. Okay. Let's say this R is a new array of the revenues. If we don't cut any rob, then our revenue is 0. Okay, that's self-explanatory. Then I start to build our R array, our revenue array. So at each point, I can either I will get the maximum of all the ways I can cut so far. So this is the core of the algorithm. And to implement that, you can see here, I is from I to j. When I equals to 1, then we get the price 1 to to revenue j minus 1. And when the I equals to j, which means we do not cut this off. We do not cut the rope at all. Sorry, here is actually we this is cut into one piece, and then when the case where you don't make any cut is here. Sorry, I apologize. This is when you don't make any cut, you sell the rob, the J rob overall, then the rob over the price plus 0, and that is what is this line doing. Okay, this is the textbook version of cut the rope. Please remember this. This is very iconic. So our solution is very similar. Okay, look at this. We want to know the number of square numbers. Let's put them into an array called DP, not the revenue, but it's really doing a very similar thing. Okay, then our final output is the number n. Then I would say for number j, j is the summation of square number I plus the rest. Okay, for example here, the 12 is the summation of square number 4 plus the rest 8. Then we break down the 8 again. 8 is the summation of the sum of square number 4 plus the rest 4, and then the rest 4 is we are done. Or let's look at another example here. 12 is the summation of the square number 9 plus the rest, and then the rest 3 is the summation of the square number 1 plus the rest 2. So you see, from the first step, from the 12, we really loop over all the square number possible. For example, here I first choose square number 4, or in another solution I choose square number 8, and in another solution we choose square number 1. So we will iterate through all the possibilities. For example, here we iterate through all the possibilities. And since we choose the number I, then DP is to record a number of square numbers chosen. Every time we choose a number, the number chosen is +1. It's very self-explanatory. Then the next is how to initialize the array. So we have to say if we find if the rest is the square number, then there's only one way to do it. We simply choose this number. For example, how do we get the combination of 16? we first check. Okay, 16 is already a square number. Then we do not break it down further. Then there's only one way to get the 16, which is 1. Here you don't want to try 5 plus 11. You don't want to try 6 plus 10. There's only one way to get one combination to get 16. Or in another example here, say the rest is 9, then okay, then we at the initialization we tell the DP array if we find a square number, then there's only one way to choose it. Okay, then simply assign number to 1. Let's look at the code. So yeah, the code is literally what I just said. First, you initialize it with the 1. This means if it's a square number, there's only one way we can do it. Then you go through the loop, which is here. It says you find every possible ways to get the number j and then return the minimum. Alright, that's all.